So the degree of difficulty in this problem is one step above what you've done so far. I mean, the picture's still going to be similar. The diagram is like the free body diagram and the descriptive equations. There's not going to be anything there that's going to be an issue. But because the unknown is the applied force, it's going to make it a little bit more difficult to solve this problem. So your math skills have to be good. So we have a level surface, and we have a 65 Newton crate. Now, because they say a 65 Newton crate, that means they're giving me the weight of the crate. They're not giving me the mass. So this number up here, always look at the unit. If it says 65 kilograms, they're giving me the mass. If they say 65 newtons, they're giving me the weight. So I can't put the number in here, but my picture, it says that the force is acting at an angle of 27 degrees above the horizontal. So, like I said before, that would be like 60 or 70 degrees. That would be 45. 27 is going to be a small angle. And let me see, I need to start over because it's not even touching my okay, so now, so we'll say that's 27 degrees. So this is the applied force, which we don't know what that is. So this is going to be the unknown in the problem. And they do give me the acceleration, and they give me the coefficient of friction. So the next thing is I'm going to take that applied force, and I'm going to break it into its horizontal component. Notice that's an arrow, not a line. So when you're making these right triangles on your picture, each line needs to have an arrow. It needs to have a direction. So that is my x component of the applied force, and then this is going to be the y component. So I'm going to have this as I'm going to have this one as FAX, and the other one as FAY. And the angle between your two components will always be 90 degrees, so a lot of times I will put a box, it's an ugly looking box, so let me see if I can make it a little bit better. All right, so that is a right triangle. And we know the angle in the problem, so I'm going to include that. The angle is 27 degrees. And there is a coefficient of friction, so there's going to be friction. So friction always opposes motion, so we're going to have friction in the other direction. So there is my friction vector. Now, vertically, we're going to have three forces in the vertical direction because we now have a component of the applied force in the y direction. So I'm going to make my weight, and I'm going to draw this arrow at least as long as this arrow over here, because I'm going to have another arrow that needs to be up, which represents the normal force. So I need to make this a little bit longer than that because my arrows up have to equal my arrow down. So this is going to be my weight, and my normal force is going to be right there. Now, all of these forces that I'm drawing, I mean, sometimes people are confused because where they are. They're all happening on the crate. So what I'm doing is I'm replacing this arrow. Notice they all start from where the crate is. But you might say, well, this one's way over there. It's not happening on the crate. Well, it is happening on the crate. I could have taken that and put it over here, so the arrow would have been on this side and then gone over. So what I'm doing is I'm replacing this vector with these two. So this one no longer is there. This has been replaced with those. So once I have the picture, and I'll put M right there because I don't know what it is, but that's where you usually write where the mass would be. The coefficient of friction is 0.3, and the acceleration is 4.5 meters per second squared. So there's the picture. So when we write our descriptive equations, we're going to sum up our forces in the x direction. And what will my equation be? What's the equation? Yes. Good. FAX minus F equals MA. So that's the equation in the x direction. Now in the y direction, what will my equation be in the y direction? Yes.
FAY plus FN minus W equals weight equals 0.
Yep. FAY plus FN minus W equals 0. Now, if you look at these two equations, here's the problem that we have. We do know mu, we do know A, we know the angle, but I don't know, like normally what I would do is I would get FAX by taking that number times the cosine of the angle because that's the opposite, that's the adjacent side. To get this number, I would take that value, multiply it by the sine of the angle, and that would get me that number. The problem is, I don't have this. So if I don't have the hypotenuse, if all I have is the angle, then I can't get numbers for these right now. So if I look at the things I don't know FAX or FAY, I don't know FN, I don't know friction. I actually do know the weight because it's given as 65 newtons. Maybe I should put that also on my picture. That's 65 newtons. So I do know that. But, and so if I know the weight, I know I can get the mass. So even though it's not on the board yet because I haven't solved it yet, I will know both W and M. And I do know A because it's given in the problem. So I need to reduce the number of variables in the problem because there's too many. I've got 1, 2, 3, 4, basically 4 variables because these aren't really variables even though I haven't yet solved for mass. I know that stuff. But I don't know these 4. I can't solve a problem with 2 equations and 4 unknowns. I need to get it down to 2 unknowns. So what I'm going to do is I'm going to replace FAX with FA times the cosine of the angle. Notice I'm not even putting in the 27 yet. I'm dealing exclusively with variables. So I'm replacing this with the hypotenuse times the cosine of the angle. So this is FAX. So I'm taking that and replacing it with that. Now, minus friction. Well, look, I've got friction in Fn. I know I can write friction as mu Fn because we have the formula, friction equals mu Fn. And mu, I know. So I'm not going to be increasing the number of unknown variables by replacing this with mu Fn. And so that's what I'm going to do. So I'm going to have my second term is going to be minus mu Fn equals Ma. So that's the first equation. My second equation, I'm going to replace this with Fa. This is the opposite side. So opposite and hypotenuse, I'm going to replace Fay with Fa sine of theta. Then I have plus Fn. So I'll put plus Fn equals, now if M was given in the problem, I would actually replace W in this problem with mg because why bother calculating it if I can just replace it? So I could, because W equals mg, so if I knew the mass, I would do it. But I do know the weight, so I'm just going to leave the weight in the problem, and I'll just, I am, because I'm still going to have to solve for M anyways. So I'll leave W. Everyone follow what I did so far? And so now I can either eliminate the FA or eliminate the FN by substituting or by what I used to call simultaneously solving. I think they call it the elimination method now in algebra classes. So I'm going to do it by the, quote, elimination method. And since I want to keep my FA, what I'm going to do is I'm going to take this whole equation here and multiply it by mu. And the reason why I want to multiply it by mu is so that the middle term will be mu Fn. And if I have minus mu Fn and plus mu Fn, I know that if I add these two equations, I will end up getting rid of that term. So when I multiply everything by mu, I'm going to get mu Fa sine of theta plus mu Fn equals mu W. So does everybody know what I did here? All I did was I just distributed the mu to each one of these terms, and now I have that. So now I'm going to take this equation and this equation, and I'm going to add them together. So when I add this with this, I'm going to get, let's do this. I'm going to get Fa cosine theta plus mu Fa sine theta. So that's now my left side because the minus mu Fn cancels the plus mu Fn. So the minus mu Fn plus mu Fn is 0. And then on the other side, I'm going to have Ma plus mu W. And I better stop it here so I don't run out of time. And I'll have to continue it with the second video. I mean, we're almost done.